In our previous video, I talked about rationalization technique and I solved two examples. So in this video, I'm going to be solving two more examples so that you will be able to understand how to use this technique to solve any limit. So let's get started. The third example, we are asked to evaluate limit n x tends to 0, 1 divided by x plus 3 minus 1 divided by 3 divided by x. This is the function that is given to us. So I told you in the previous video that the first thing you have to do is to plug in what your x is tending to. In this case, our x is tending to 0. So we'll be plugging in 0 and check if our answer will be equal to 0 divided by 0. Now let's check. Let's put 0 here. If we put 0 here, we have 1 over 0 plus 3 minus 1 over 3 divided by 0. So we have 1 over 3 minus 1 over 3 divided by 0. So we have positive 1 over 3 and negative 1 over 3, they will cancel. So as you can see here, our answer will be 0 divided by 0. 0 divided by 0. So 0 divided by 0, sorry. 0 divided by 0. So we cannot leave our answer like this. We have to use this technique called rationalization. Now, let's get started. Right? Limit. Let me write our function again. X tends to 0. 1 divided by x plus 3 minus 1 over 3 divided by x. So, what you have to do here is to multiply what's at the top here with what is in the denominator. Like here now we have 1 divided by x plus 3 minus 1 over 3 divided by x. So let's first, like I don't want to use that technique. Let me use this method to solve, because this one is easy. Let's find the LCM of this here. So we can just find it here. LCM. We have 1 over x plus 3 minus 1 over 3. So we have 3x plus 3. This multiplied by this. This multiplied by this, it will give us this and this will cancel, so we have 3 minus x plus 3. So this is what we have here. How do I get this? I want to take the LCM. We have you have to, like, for us to be able to take the LCM here, we have to use 3 multiplied by this. That's what I wrote here. 3 multiplied by x plus 3. So we now divide this by this. 3 into x plus 3 divided by x plus 3. Let's write it somewhere. I want you to understand this perfectly. 3x plus 3 divided by x plus 3. As you can see, this and this will cancel. So we have 3 left. That's how I obtain this 3. And 3 multiplied by 1 is 3. That's how I obtain this 3 here. Then we have this as well, which is 3x plus 3 divided by 3. So 3 and 3 will cancel. We have x plus 3 left. X plus 3 multiplied by 1. We have this negative x plus 3. That's how I got this here. So we can now rewrite our limit here. X tends to 0. So this is what we now have. This is what we now have. We have 3 minus x plus 3 divided by 3x plus 3 then everything over x, this x here. So we only took the LCM of this and we got this, so divided by our x here. So this is what we have so far. The next thing we have to do now is in this stage we are now, what we have to do is to multiply, to take this our x up here and multiply it by this our function here. So we'll multiply x by this here. We are trying to clean up this equation because it's too complex. We now have 3 minus x plus 3 divided by 3x x plus 3. Yes. What have I done so far? I multiply this by x. If I multiply this by x, I have 3x, then x plus 3. Yes, so this is what I have so far. Now, positive x will cancel with this one. If we open the bracket here, we have negative x plus 3, negative x minus 3, sorry, then we have 3 here. So I think I should, let me write this so that you understand what I mean. We have limit x tends to 0, 3 minus x minus 3. What have I done? I open this bracket. If I open it, I have this 3 here, then minus x minus 3 divided by 3x x plus 3. So this is what I have so far. So we have positive 3 and negative 3. This and this will cancel. So both will cancel. What did I have so far? I have limit x tends to 0. We have minus x divided by 3x x plus 3. So this is what I have left. Can throw this away. So we have x here. We also have x here. We have x here. We have x here. So it will cancel. This x will cancel with this x. So what do I have left? I have limit x tends to 0 minus 1, because x here goes here one time. So minus 1 divided by 3x plus 3. So this is what I have so far. So now we can now plug in our what x is tending to, which is 0. Let's put it in our function. Minus 1 divided by 3, 0 plus 3, which will be equal to minus 1 divided by, we have 9. So that is our answer for that limit. So what have I done so far? I checked and I found out that our answer will be, if I plug in x, if I plug in 0 in, and if I replace x with 0, I know that the final answer will be 0 divided by 0, and I can't leave our answer like this. That's why I have to use this technique to solve it the way I did in the previous video. So I'll be solving the last example here, and it is, we're asked to evaluate, which is the fourth one. Evaluate. We're asked to evaluate this limit x tends to 0. We have x divided by 1 divided by x plus 4 minus 1 divided by 4. So this is what I have so far. So we have to evaluate this limit. So if we plug in 0, you can check it out. If I plug in 0 into this function here, the answer I will be getting will be 0 divided by 0, and I can't leave it like this. That's why I need to use this technique. So we do the same thing, like the same thing we did in the previous video, in the previous example, sorry. So we have limit x tends to 0, x divided by 4 minus x plus 4 divided by 4 x plus 4. So this is what I have so far. I took the LCM of this the way I did in the previous example. So you just take the LCM of this. If I take the LCM of this, I obtain this here. So let's move on. Here we have x. So the same thing we did. You have to multiply this x by this here. This equation here. You have to multiply this by this here. So we now have, you have to multiply x by this function, this equation here. So we now have limit x tends to 0, 4 x plus 4 multiplied by x. So I've multiplied it by this x here now, divided by 4 minus x plus 4. This is what I have so far. Then this 4 will cancel with this. With this negative 4 will cancel with this one here, and it also cancel with this. So this is what we have so far. We now have limit x tends to 0, 4x x plus 4 divided by negative x. So we have negative x and positive x here. They will cancel. What do I have left? I have limit x tends to 0, 4. I have 4 x plus 4 divided by negative 1. We still have negative 1 here because it goes here one time. Now I can now put my what x is tending to into my function. If I put it, I will have negative 4, 0 plus 4. So my final answer will be equal to 16. Negative 16, sorry. Negative 16. So that will be our final answer. So what have I done so far? I took the LCM after noticing that my answer would, the answer I will obtain, it will be 0 divided by 0. I took the LCM of this and I obtained this here. After obtaining this, then I check this. If I multiply this by this, this one will be negative x, negative 4. So this and this will cancel. And it's also cancel with this positive 4 at the top here. So I find out that it is this here. Now I plug in my 0 into the function and I obtain negative 16. So that's all for rationalization technique. In the next video, I'll be solving more examples on limit. Thanks for watching.